All right, so I want you to look over those topics right now. I have selected a few questions out of your packet to do, but those questions are not as important as your questions. So I'm going to let you take about 2 minutes right now, look at the topics that are all on the test tomorrow, look at all these topics, and then I want, hey, what do you mean by that? Can you give me an example of that? All right, review that topic here with me. All right, now is the time for you to ask those. Because unfortunately, I am not after school today, all right, for any extra help. So it's going to be now or never right now. Unless you're coming in periods 4, 6, or 8 to review. If you have study hall or lunch, I'll be here 4, 6, and 8, but no teachers available after school today. So now is the time to get all your questions asked before I select a few, but the ones I selected aren't as important as your questions. Bailey, where are you going to start today?
Can we go over function notation?
Function notation, sure. So let's just go over all the different notations for translations. All right, so if I'm doing a translation, all right, let's say I'm going to go, let's go right 3 down 2. Let's go over the 3 different ways you could see this tomorrow. If I'm going right 3 down 2. First is your function notation. X comma Y. Got to start with that. That's non-negotiable. Implies, arrow. Now in the second set of parentheses, you're going to tell me what the X is doing and what the Y is doing. So how do I represent right 3 down 2? What do I write in those parentheses for right 3 down 2? Let's get reviewing. Right 3 down 2, what's going to go in those parentheses, Brendan? X
plus 3.
Yep, and good job. So there's function notation. Vector notation is these right here, look like your inequality symbols with just the numbers inside. So right 3, down 2. And then finally, I don't have a name for this, we just called it other. That's using capital T with the subscript right 3, down 2. Okay, so that's what all 3 different notation. Everything means the same thing, just written differently. It's a translation of right 3, down 2. All right, next. Others you want to go over here? There's got to be something here that, if this comes up, I'm toast. Let's go, Cormac. What's up?
Can you go over proving triangles?
Yep. I got you. Here you go. Everyone go in your packet right now is going to do this. We'll do this later. We'll do it now. Everyone, number 22, please. 22. Because there is certain wording that I need for full credit. All right, certain wording in your explanation that I needed. So look at number 22. I picked a real easy one so we could go quick. Are these 2 triangles congruent or not? First thing you need to do tomorrow, figure out how to get one on top of the other. So how do I get ABC on top of DEF? What transformations need to occur? First thing you should look at, orientation. Here you go. As I go from A to B, B to C, C back to A, what type of orientation am I going? A to B, B to C, C to A. What type of orientation is that? Clockwise or counterclockwise, Vinny? That's clockwise. Yep, it goes in the direction of the clock. Now I match it up to D, E, and F. Go again. D to E, E to F, F to D. What direction am I going for this one? 17, Dylan. That's counterclockwise. Oh, they're opposite each other. So I know a reflection has to be involved. All right? At least one reflection. All right? An odd number of reflections. So I'll let you guys look at that. Those 2 figures. Again, I made it easy on you. It's going to be a lot tougher tomorrow. But how do I get ABC onto DEF? And get specific for me. Just don't tell me a rotation, a translation, a reflection. Get specific with your description, please. And then we'll talk about what wording we needed in here. All right, so how do I get ABC on top of DEF? We already discussed what's definitely involved. All right, I don't know if there was more involved, but we know definitely what's involved. So how do I get one on top of the other there? Ooh, here we go, Micaiah, back to you back there. All right, and that was it. Now, it only took 1 there. Tomorrow, it might be, hey, reflect over the y-axis, translate right 3 down 2. All right, so don't just assume it's 1 tomorrow. It might be 2 transformations. So what am I looking for here? Here we go, triangle ABC. is, and then you're going to tell me what we're doing. Reflected over the y-axis. Now, hey, tomorrow it might be followed by another transformation, right? So be prepared. It's not going to be this easy. Reflected over the y-axis. And now we get in this whole explanation of why they're congruent. Reflections, because that's what you told me you did. Reflections are, what do we call reflections, translations, and rotations? They're all what type? Types of rigid motions. There we go. Are rigid motions. Still not even close to done. Which, now tell me a little something you know about rigid motions. Preserve. Yep, preserve distance. And angle measure. There you go. And now you can get creative on me tomorrow if you feel like it. I'll go therefore right now. Therefore, triangle ABC congruent to triangle DEF. All right, that's the wording you need. Now, the only thing that'll change is maybe it's not a reflection, it's something else. And it might be 2 transformations, 3. All right, I can probably bet it's not 1, though. And there's more in your packet, too. You know, the one right below there, number 23, I think, involves a little bit more than just 1. So, all right, so take a look at those. All right, good job there, Cormac. Anybody else? Let's keep looking at your topics here. Anything else we want to go over? There's a lot on here. And not my confidence isn't that high with a 3-day weekend in between here. Yes, Lauren, let's go. What do you got?
Go over dilations of a line.
Dilations of a line, you got it. Let's go to, I had one set up here, number 34, please. Number 34, everybody. So I'm going to take this line, dilate it with the center at the origin. What's the equation of the new line? First thing to check. Whoa. First thing to check. Is the origin on this line? Because if it is, this is an easy problem. It stays the same line. All right, so how can I tell if the origin's not on this line or not? Yep, you guys are figuring that out. I'm going to graph it and figure it out. So I go to my calculator. Let's graph it. I go to grapher. Negative 3x plus 4y equals 8. I first want to check, is the center of dilation on the line? Because if it is, this is an easy problem for me. It just remains the same line. So I type in negative 3x plus 4y equals 8. There's a couple different ways we could figure out if 0, 0 is on this line. We could go to the table and see if 0, 0 is on there, or we could just graph the darn thing, right? So I graph it. Is 0, 0 on there? No. Okay, so I know it's not going to stay the same line, but at least I know now it's going to be parallel to this line. Right? So I notice 0, 0 is not on this line, so it's not going to remain the same line. But when you dilate 2 lines, they remain parallel to each other. And what stays the same then if they remain parallel? Slope. So if you can tell me what the slope of this line is, I can tell you the slope of the dilated line because they're going to be the same. Now, how do I do that? How do I figure out what the slope of this line is? 2 ways. You turn it into y equals form and tell me the slope. Or, quick recap, I know some of you probably forgot already. If you go back to the equation, you guys have 3 dots over here. You have 3 dots. You can go to those 3 dots and hit details, and it'll tell you what the slope of that line is. Now, the only part I don't like about this is it will never give it to you in fraction form. But if you know 0.75 is 3/4, okay, that's fine. All right, so you can go to details or you can put it into slope y equals form yourself. All right, so here the slope equals 3/4. So I know my dilated line has to have a slope of 3/4 because they're going to remain parallel. Now, does it affect this problem that it did not give me a scale factor? No, because look at my choices. They're all different slopes. I'm looking for the one that's got a slope of 3/4. If it did, right, let's say it gave me a scale factor of 1/2. So now, Laura, I take the 1/2 and I multiply by whatever the y-intercept was here, which I can find. Go in here, okay? Or you turn it into y equals form yourself. You're going to get 2. So I do 2 times, in this case, 1/2. It tells me what my new y-intercept is. Good job. Anything else there? Dilating a line. All right. Also notice on the topic of dilating, lines aren't going to be the only thing you dilate, right? We're also going to dilate a point, all right, which is a little different than the line. Others we want to go over here. I still got more to go. You guys have picked 2 topics already I had needed to go over, but we need to go over a couple other things. Yep, Stephanie, what's up?
Same versus opposite orientation.
Same versus opposite. All right, let me go back to, so this right here would have opposite. Okay, that's what I mean by opposite. So reflections are always going to give you opposite orientation. Same orientation is they're both going clockwise or they're both going counterclockwise. That'll be your translations and rotations. Okay, that's what I mean by same and opposite. All right, anything else? Because there's going to be a question on that tomorrow. I'll give you 2 figures and I'm going to ask, is this same or opposite orientation? All right, what's up, Tess? Yep, invariant points. You got it. Let me get a grid up here. Grid. Visible. All right, quick. Tess is asking about what's invariant points again. All right, let me graph a quadrilateral up here. Here's point A. Here's point B. Here's point C. And we'll throw point D over here. Okay, here's my quadrilateral. I'm going to do this. What am I about to do? What's that a symbol for? Reflect, and I'm going to reflect over the x-axis. How many points remain invariant? Meaning they don't move. I'm going to perform this transformation, and that point stays right where it is. Is A going to move? There's 1 point. B going to move? Yep, over here. C going to move? Yep, how about D? Nope, so that's 2 points that will remain invariant. 2 points. All right, versus what if I reflected over the y-axis? Would any points remain invariant then? No, they're all going to move. So invariant points are points that do not move after I perform the transformation. Good? Anything else here? Keep going. You guys are doing nice. A lot more questions than I thought, which is great. Anything else up here? But I got a couple more problems in your packet to do. All right. First, there's 39 questions here. 39 questions. All the answers are in the back of your packet. None are on Classroom. All right. The answers are in the back of your packet. 39. Okay. That's up to you what you want to do with those 39. We're going to go, you guys have already done a couple of them, but let's go to 12. There's new notation up here. I think you can assume what it is, but I just want to make sure we're clear. Which one of these is not a rigid motion? If you remember, rigid motions do not change size or shape. I just want to make sure you were good up here. What do you think that capital, I never use it, but that capital D, what do you think it represents? Dilation, and what do you think that 2 is underneath? Good job, scale factor. All right, the capital D means a dilation. Number underneath means the scale factor. So which one of these is not a rigid motion? Which one does change size or shape? Dilation, yep. Never a rigid motion, all right? It'll result in something similar, right? Similar figures, but not congruent. All right, go ahead, go to 14 for me, please. 14, we got to go over compositions. 14. All right, I want you to take -2, 3 and perform this composition. First, how did I even know this was a composition? Whoop, symbol. All right, looks like a degree symbol, but it's not. That tells me composition. And there's one other piece I'm worried about. How do you perform them? What's done first here? Right to left. Right, we do these right to left. We're going this way. Right to left. So yes, I'm going to do a dilation first. We can assume, unless it's stated otherwise, we can assume it's around the origin, centered at the origin. So a dilation of 3, centered at the origin, which means I can use my shortcut here. All right, I don't need to, you could graph it and go up and over, right, 3 times. But we can use the shortcut and take my scale factor. So -2, 3. Where's that going to go after a dilation of with the scale factor of 3? The scale factor of 3. Where's that going to go? What's my new point there? Micaiah on fire back there. -6. Why -9? Just 9, right? If you're wondering where she came up with those coordinates pretty quick, she used the shortcut, multiply by the scale factor. Now I keep going to the left. I take -6, 9, and now I reflect over the y-axis. Okay, now I take -6, 9, reflect it over the y, and find out my final coordinate. And if you reflect that, it should end up at 6, 9. All right, 6, 9 after you reflect over the y-axis, not the x, the y. And the only other thing I was going to do with you guys, I'm not going to, I wanted to talk to you about it, is I'm putting a construction on there tomorrow. Now, it's one of 2. It's not a secret. It's one of 2. Dilate by 1/2 or dilate by 2. It is not a secret. It's going to be one or the other. And you have both examples in your packet, number 39 and number 40. Or 38, 30, I don't know which one, but one's 1/2, one's 2. It's not a secret. It's going to be one of those 2. All right, so I'm not going to have any sympathy if you don't want to remember the steps, because they're not that bad. All right, so it's going to be scale factor 1/2 or scale factor of 2. I don't care who you work with. If you want to move around and work with other people, the entire answer key with work is in the back of your packet. You should not have to go on Classroom for any answers. All right, they're all in the back of your packet. All right, all 39. Do what you want with the 39. Call me over if there's questions, but again, you want to work with somebody else and move around, feel free. All right, feel free. Hopefully this isn't the